Alrighty. So this week, also we actually start combining our chapters also. So as you will see this week, you guys are working on a combination of chapters 5 and 6. They are both related to probability. So chapter 5 kind of introduces you to probability and the basic rules about probability. And then in chapter 6, we'll get into discrete probability distribution. And then, we'll continue that discussion about probabilities as we move forward also. So when you get into the next chapter, we'll be talking about normal probability distribution. So we're kind of getting into a second part of statistics here. So chapters 5 and 6, you're still working on 5 sections. So the number of sections is not increasing, even though we are doing 2 chapters, because, your textbook is kind of interesting in that way. The older textbook that we use, they would combine this into one single chapter. Your textbook breaks it up into 2 chapters. So I don't want you to focus on the fact that it's 2 chapters. Just remember the content material is actually the same. It's just the way your textbook is designed. So in a different textbook, this would all be 1 chapter. Your textbook is just breaking it down into 2 chapters. So chapters 5 and 6, you're working on sections 5.1, 5.2, 5.3, and then 6.1 and 6.2. So again, guys, you will have, your reading assignment, viewing assignment. You will have then your discussion post and your activity for this week. And then you will have your My Stat Lab homework quiz and exam. So again, if we go down over here, you'll see your reading and viewing assignment. So again, I have broken these down by chapters. So you should be able to get into your chapter through the textbook, or if you want to look at the handouts, you can do that. And then, of course, under your viewing assignments, again, I've got crash course statistics videos to kind of give you a base over here, just a basic information, and then your chapters 5 and 6 videos. So again, you can watch through that, look at some concepts, some examples. And then here is the learning activities portion. So we've got our discussion post and our activity. So your discussion post this week is also a podcast. And this one is actually a very interesting podcast because this one talks about, this doctor had come up with a new dialysis machine, I believe, not a treatment. I mean, I guess it was both. So he comes up with this new treatment, this new machine, but because the machine is located at this one hospital, one clinic, it's not available nationwide. And they had to be very particular about who got to use the machine, right? So this was, again, sort of that sampling idea of how do we choose patients who should receive this treatment. So it's kind of very interesting as you listen to, and it's not a very long podcast, it's just 20 minutes. Because you're only listening to one act. You don't have to listen to the entire podcast. And so they're talking about how the selection committee, chose patients who would receive treatment. And you can kind of see where that name God committee comes from, because they basically decided, right, who gets treatment, who gets to have a good long life, and who doesn't get treatment and maybe unfortunately didn't survive. So it was kind of a very interesting way to see. And, they talk about how they tried to keep personal biases out of their selection process, how they wanted to make sure they were making a good, reasonable judgment, and as you will listen to the podcast, you will find out, if they were successful, if they had a good process, or if they did not, what are some things that we can learn from that. So as always, guys, your initial post will be due today at midnight. Questions over here so you can answer your questions based on this. And again, I did yesterday go in and make sure that I had checked my settings, so you should be able to go ahead and add your responses. So you will see it does give you that option, so you will be good to go on this Flipgrid video. So you will be recording your responses as a video for this one. And then, of course, your peer replies will be due on Thursday by midnight. And again, you can leave a video response, or you can just type in a comment, whatever you are comfortable with. So just remember, like I said, this will be the last week you will be working on any of these discussion post, and then also this assignment. So since our chapter for this week is focusing on probability, I kind of wanted to do an activity based on probability. And we are actually focusing more on the binomial probability distribution. So let's talk a little bit about this over here. So when you're talking about a binomial experiment, there are certain rules that you have to follow for it to qualify as a binomial experiment. So, these 4 requirements are basically that you have to have a fixed number of trials. And you'll kind of see how I'm bringing in all of these different concepts into our little activity that we are doing this week. So fixed number of trials, which means you are doing the experiment, so many number of times, right? So that's got to be a fixed number. It's not going to be like infinity. You just keep doing those experiments. The second requirement is that each trial has to have only 2 outcomes, or outcomes that can be reduced down to 2 options, basically. So, we're going with flip a coin, which makes it easy, right? Because you have 2 outcomes. You either land on a head or you land on a tail. If it was something like, rolling a dice, well, then in that case, let's say we take a regular 6-headed dice, right? And we were interested in, well, how many times does the dice land on, I don't know, number 5? So your outcomes would then have to be reduced down to 2 outcomes. It either lands on a 5 or it does not land on a 5, right? Because you wouldn't say, oh, it landed on a 1, it landed on a 2, it landed on a 3. No, we would say, did we get a 5 or did we not get a 5, right? So you're reducing it down to 2 outcomes. So that's kind of one of the big things when you're working with these binomial experiments. The other one, as you can see, is the outcome of each trial must be independent from each other. In a dice or a flip of a coin, it really wouldn't matter so much, but this would matter, let's say if you were playing with a deck of cards, right? So if you were choosing a card from a deck of cards, so we know a deck of cards has 52 cards, right? It's got the 4 suites, each one has 13 cards in it. So let's say we, shuffle our deck and we picked a card and it came out to be, I don't know, Jack of a club or something like that. Now, the idea is if you take that card and you set it aside, right? You don't put it back in your deck, you actually no longer have independent events. Because what happens now, and if you guys have not done probability yet, if you haven't read through part of chapter 5 yet, let me just kind of show you this. So when you have 52 total cards in a deck of cards and we choose 1 card from it, that's a probability of 1 out of 52, right? A very small probability. So, we have a Jack of, what did I say, clubs that we got out. So if you take this card out of the deck, your deck will now only have 51 cards, right? So if you shuffle the deck again and pull a card out, that means your probability has changed and it's gone down from 1 of 52 to 1 of 51, right? Because your deck is smaller now. If you take another card out, I don't know, 2 of hearts. Well, now your deck is down to only 50 cards, right? So your probability again has changed. So that actually means your events are no longer independent. They have now become dependent on each other. However, if you pull a card out of a deck of cards, you look at it, maybe write down, okay, this is the card that I got, and you put the card back into your deck, then you don't have a problem because that makes it independent events. Because if I put the card back into my deck, my probability will stay the same, right? Because I have all 52 cards now in my deck. So that's kind of one of the examples to think about, when we're talking about, do you have independent trials or dependent trials? So that's something we always want to make sure with binomial experiments. And the last one is the probability of success has to remain the same for each trial. And that kind of ties back into what I was talking about with the deck of cards, because, if we kept keeping those cards outside, then your probability of success would change because we went from 1 out of 52 to 1 out of 51 to 1 out of 50, right? So that probability changed. But if your events are independent, then more than likely your probability should also remain the same for each trial. That should not change. So remember, whenever you are working with binomial probability distribution, you are thinking about these 4 requirements for a binomial experiment. So we will make sure that we meet all 4 of these requirements in our little experiment that we are doing here. And in this little paragraph over here, they kind of talk about just different types of outcomes that you can think about that could be considered as a binomial experiment. So, I talked about the 6-sided die, you can land on an even and odd number. So that can be 2 outcomes. In a basketball game, you are either winning or losing. In a true or false question, obviously either the answer is true or it's false. So again, 2 outcomes. Some of the other examples where you can reduce it down to 2 outcomes is they're talking about a medical treatment, if it was effective or ineffective. A person can be classified as having normal or abnormal blood pressure. So again, 2 choices down to that. With a multiple choice question, kind of the same thing. You can say, okay, if you have, 4 or 5 answer choices, well, again, multiple choice, most of the time, you would have the correct answer and the incorrect answer, right? And there can be 2 answers could be correct, the remaining of them could be incorrect, but you can still break it down into those 2 outcomes. So just different situations where even if you don't have by design 2 outcomes, you are able to break it down into just simple 2 outcomes. And that's what you're always looking for with these binomial distributions. So just some information here, background information to kind of get you started. And then here is where we start with our assignment over here. You will actually be using this binomial distribution table later on, and I've got another link for it down here also in your questions, but this was again just to kind of get you started thinking about it. So for this activity, obviously, since it's called flip a coin, you need to have a fair coin, and fair coin means it's weighted equally on both sides. So, it's not going to keep landing on just one side. So anything you have in your wallet should work, and I would say pick a slightly heavier coin. So you don't want to go with, a penny, dime or nickel, quarter or anything larger than a quarter, dollar, half dollar coins are fine. If you are like me who never carries money on me, if you find any money in my wallet, that's a good day because I'm just not a paper money person. So, again, my favorite website is random.org. So they have a coin flipper. And actually Google has one too, but I did not like the results that I got from Google because it kept giving me 50-50, like 5 heads and 5 tails. And I didn't like that because you want some variety in this experiment. So I like this one that random.org has. So you can do, 1 coin at a time. And I love this. They have all kinds of different coins here that you can choose from. So, if you want to do an American coin, that's fine. If you want to just do something random, I don't know, we'll use the check. So this one, if you're using a new coin, do a few flips to recognize what is the head, what is the tail. So that way, whatever you're classifying as a head or tail. So normally where the, amount is, that's your head. And then the flip side would be your tail. And that looks like, I'm not sure what that looks like. Some kind of a lion, I think. So again, that's your head. And the way to know that your coin has flipped, because, obviously this is virtual, look at the timestamp because the timestamp will change. So you can see we're at 17:33:36 when I flip that coin because I'm landing on head over and over again, but you will see that change from a 36 to a 48. If I flip that again, you will see it change to a 55. So that's how you know the coin has flipped when the timestamp changes. So, just little nuances you got to be aware of when you're using these virtual coin flippers. So if you don't have a physical coin, you can do this virtual one over here. So the way you're going to be doing this is you are actually going to flip the coin 10 times. For each flip, you will record your outcome, right? So did you land on a head or a tail? And then you're repeating this experiment 3 times, basically. So actually, you'll be flipping the coin 30 times, if you will look at it that way. And in this case, we are going to let X variable represent how many heads did you get. So we're actually counting the number of heads. N will represent the number of independent trials that you do. P will represent the probability of success. And in this case, when we're talking about probability of success, because we're counting the number of heads, the probability of success would be, how many times when you flip a coin, what's the probability that you will land on a head? So that would be the probability of success. So that means probability of failure would be when you land on a tail, right? Because since we're focusing on head as a success, tails would be the failure. And you will record your outcomes and the calculations that you will be doing on this spreadsheet over here, flip a coin. And I've actually put my results at the top, so you kind of have an idea of, what to type in when you're doing this. So let me again go ahead and make a copy of this so we can work on this together. And I'll close the original. Let's make sure I give you editing rights on this. All right, so again, guys, you should see this link coming through chat on Zoom. And this one, I do want you guys to go in because as you can see, you will be entering your information because we're going to be doing first part of this experiment together in class today. So please make sure you click on this little link. You will need your ames.edu email address to log in. So it wouldn't do if you have like your own Gmail account or something. So you will have to switch to the Ames account to get into this document. And as always, you will see on the second page of this document, we have the second part of our experiment. So the first part here is we're doing the coin flips and we're recording, what our coin is landing on, heads and tails, and how many heads and how many tails you have. And then we'll come to the second page, and this is where we will be working on completing our table over here. So there's two parts to this document over here. Okay, so I'm seeing 3 of you have logged in so far in there. So again, remember guys, the original document that you have, that the link I have over here will be only a viewer copy. So you will need to make a copy of it like I just did, or you will need to download it to an Excel file. So whatever, works for you. Download it before you put your information in there. So that way, if anything changes, once you download it, then you can update it and you won't lose your data. I've given you some links again here from your textbook if you wanted to go and get a little bit more information on how to work on the binomial distribution table and that sort of thing. So the first thing we are going to be doing is doing the experiment itself. So we need to start with the coin flips, and then once you're done with the coin flips and you've recorded your number of heads, how many total heads you have, then we can come down to some of these calculations here. So here's another thing that you can do, one of those time-saving techniques. Will this not go back? Okay, there we go. And I'm actually just going to switch to an American quarter over here. I don't know. I guess we'll do New Jersey. So to save time, you can actually do, 30 coins at the same time. The only issue with this would be keeping track of all the heads and tails you've got. So you do have that option, or what I normally do is 10 at a time. So that would be, one experiment. Seriously, that's a whole lot of tails in there. So you can do that. You can do 1 coin at a time. Honestly, it doesn't matter. But as you can see, you need to start recording, your first trial, did you land on a head or a tail? The second one, where did you land? The third one. And then you fill in your outcome, and usually we fill in the outcome in the order that your trials, gave you the heads and the tails. And this is, the total should come out on its own because I've actually put a formula in there. So it counts every time you type in an H. So it will automatically tell you in your first experiment, how many heads did you have, how many in the second, and how many in the third. So you will see on my first experiment here, I used the Google coin flipper. And like I said, I didn't like it because for each of my 3 experiments, I got 5 heads and 5 tails. And, we want a little variety so that we can get a good binomial distribution table. So that's why I then went to the random.org coin flipper, and you will see I came up with at least, three different values for how many heads that I had. So that's why I'm kind of partial to the random.org. And I did that Google one several times and I kept getting 5 and 5. And, we don't want that. So go ahead. If you want to use an actual coin, that's fine. If you want to use the random.org one, you can do that. Make sure you put your name here so I can see, where you guys have your outcomes at. So, go ahead, start working on your coin flipper, get your 30 experiments done, and let's see what are the number of heads each one of you are coming from. And remember this answer, since you are doing 10 trials for each experiment, you can get anywhere from 0 heads to 10 heads, right? Because all of your coins could land on tails, so you could have 0 heads, or all of them could land on heads, and you could have 10 heads. So you should have a number anywhere between 0 to 10 for this. So take your time. Like I said, if you want to use an actual coin, that's fine. If you want to use random.org coin flipper, you can do that. So just pick a spot, put your name in so your classmates will know that box is taken, so they will not. And you should have enough spaces in here that all of you should be able to claim a box, put your name, and start doing your experiments. And if you're doing a single coin at a time, just remember to look for that timestamp to change. So that way you know your coin has flipped. Here I see Caitlin, Ali, Rachel, you guys have claimed your boxes. Mariah already. And since you will have access to this copy file, you can basically just copy and paste these results that you get when you do the activity yourself to submit it. You don't have to redo this first part that we're doing together. So you're basically starting out the activity in class today, so that way you won't have to repeat any of this once you are ready to work on it. All righty. I'm seeing answers coming through from Mariah, Caitlin, Rachel. Are the rest of you having trouble getting in? Okay, I see Lourdes in there, Ian. Montserrat, is it not letting you go in?
So I think I'm on it, but I don't see anybody else. So I don't know if I'm on the right one, or
Okay,
do I have to make a copy of it?
let me send you the link again. You may be in the original file.
Oh, okay.
Yeah, because if you're in the original, then you wouldn't see anyone. So we're actually working on a copy here. So I'm sending it through the Google Zoom chat, the link.
Oh, like to the group chat on the Zoom?
On the Zoom, yeah.
Oh, okay. I think I was on the wrong one.
It's okay.
Thank you.
Yeah, you're welcome. I'm actually going to stop sharing while you guys are filling that in. And I'll go back and share once we're ready to talk about the second part. Alrighty, very nice. So I see, Mariah, you've got 5 heads and then 7 and 7. That's good. Ali, your first experiment was 5 heads too. Caitlin, you also had 5 heads. Wow, 5 does seem like a popular number today. Rachel, you've got 4 so far. Okay. Lourdes, you also ended up with 5. I'm telling you. Ian also has 5. This is so weird. Okay, you've got 6 for your second one. Very nice, Caitlin. You've got 3, so a little bit of variety there. Because, you know, it kind of gives you an idea of the pattern that will show up if you can have more, you know, numbers from 0 to 10. Ian, I'm kind of liking your last experiment over there. So it's giving us a little bit on towards the lower end of the number here. Let's see. Okay, looks like you guys are almost done here. Okay, so we have 577 from Mariah. Caitlin, you had 535. Rachel, you've got 465. Wow, Lourdes, really? You had all 3 5s. My God. Ian, you had 5, 6, and 2. That's good. And then Montserrat, looks like you have 5 and 6 so far. Just give you guys a couple seconds to wrap up your final count. Montserrat, just make sure you're putting your name where it says name of student, so that way we know this is your experiment.
Okay, thanks.
Yeah, you're welcome. So yeah, and I am really surprised that so many of you, or actually I think almost all of you at least have 1 5 in your experiment. Okay, so now that you have your number of heads, you know, make a note of it so that you know what your number of heads were, because now we're ready to move to the second part of the experiment. And this is where, you know, actually, let's go back over here. So it says, you know, after your experiments are completed, you will do the following. And I'm asking you to round your answers to 5 decimal places, because some of these probabilities can be so small that you may actually end up with 0.00 something before some digits actually start showing up. So that's why we want to do 5 decimal places, so we can at least have something better than, you know, just a bunch of zeros. So keep that in mind. So now we are going to be constructing a binomial distribution table. And as I'm telling you, this is on the second worksheet. So just at the bottom, you will see, just go to the second tab and it will bring you over here. And again, claim a spot and, you know, put your name on the top, and then the number of heads you had on that first page, just bring them over. So, you know, like I have 3, 4, and 5. So I'll go ahead and put my name here. And then I had number of heads as 3, 4, and 5. So I'm going to go ahead and put that in here. I'm not sure what that's coming from. Okay. So again, as you can see, you should have more than enough spots in here. So claim a table and go ahead and put your name on it. And you know, if you have a repetition of the number of heads, then obviously you just need to do the calculation for one, and you can copy it over to the other side. So like Caitlin, you had the 2 5s in there. Montserrat, looks like you have 2 5s in there as well. I know one of you, was it Lourdes? I think she had, you had all 5s, isn't it? For all 3 of your experiments. So that would
I
just
think
be
that,
one. Go ahead.
sorry. I think I put my name on someone that was typing in their number, so I'm gonna go ahead and take that off. I just
Oh,
wanted to
okay.
let you know.
Okay, no problem.
Okay.
Yeah, so hopefully you should have enough boxes here to take as your own. Okay, so now let's talk about once you have transferred your number of heads over, how do we calculate this? So as you can see, n represents the number of trials. So number of trials, and if you look back on the first page, you will see, we did 3 experiments, but each experiment had 10 trials, right? So your number of trials is basically in each experiment, how many times did you perform the actual, activity? And that was 10 times. So that's where this n equals 10 is coming from. So that's going to be our number of trials. So don't count it as 30 because it's 3 separate experiments you did, but each experiment, had 10 trials. So that's why the number of n is going to be 10 over here. X obviously represents the number of success, which is how many heads that you get. And we already transferred that over to our table. Now, P represents the probability of each trial. So this one again, and let me get my, oh, no, what did I do? There we go. So again, you are flipping a coin, right? Which means you only have 2 outcomes. You either land on a head or you land on a tail. Well, one of those outcomes is landing on a head. So the probability that you are going to land on a head is going to be 1/2. The probability that you're going to land on a tail is also 1/2, right? Because you only have 2 outcomes. So that means I can either land on a head or I can land on a tail. So you actually have a 50-50% chance, right, of landing on a head or a tail. So that's why that 1/2 translates into a decimal of 0.5. So that is going to be your probability. If we were doing a deck of cards, then our probability would be 1 out of 52. If we were rolling a die, and if that's a 6-headed die, your probability would be 1 out of 6. So it depends on how many total outcomes you have. And then looking at the experiment, you would know what your numerator should be. If we talk about the deck of cards, let's say we wanted to know what is the probability that you are going to get a card that belongs to the suite of hearts, right? So it could be a heart of anything, ace all the way up to king and queen. So in that case, your probability would be, because since we are interested in just the card has to be a heart, it doesn't matter what, number or what value it was. So since there are 13 cards in a deck of cards which belong to the heart suite, that would be a probability of 13 out of 52, which that will actually reduce down to 1/4. So your probability in that case would be 0.25, right? Just a quarter. So in that same way, the probability that you are going to land on a head is going to be 0.5. So that is going to be your probability for this experiment. And obviously it will stay the same for all the experiments, all the trials. And that was our requirement, right? You should have a fixed number of trials. So we have 10 trials in each experiment. You have to have, oh, that terminology just flew out of my head. Fixed number of trials. Each trial has to have 2 outcomes. So we have heads or tails, the 2 outcomes. Each outcome must be independent. So obviously our coin flips were not, if you flip the coin the first time, that would not affect how you would flip the coin the second time, right? So each experiment, each trial was independent, and our probability of success is going to stay the same because it's always going to be 0.5. So we're definitely meeting all 4 of those requirements. So now what you have to do is calculate your probability. We know for each individual trial, the probability is 0.5, but now we want to know what the probability will be based on, well, how many times can we get 3 heads, or, how many times can we get 7 heads? So that probability calculation is what you are doing based on this formula over here. And I've shown you an example over here. So if you're doing 3 as the number of heads, then, that's your X value. And your n value is, of course, going to be your number of trials. Your p value is 0.5. So all of those values are already given to you. Let me go ahead and open our notebook here so I can kind of show you how this formula works out. Okay, so we're calculating what is the probability that we are going to land on 3 heads, out of our total 10 trials. So this little notation that you are seeing over here, the C and X, this is what we call as the combination calculation. And we're not really focusing that a whole lot in here. If you've done a previous math, calculation class, you might have come across permutation and combination. So that's where this guy comes from. And we define it as there we go. So you can see, we use factorials. That little exclamation point next to it is considered a factorial. So you would be doing, n factorial, r factorial, which in our case would actually be x, and then n minus x factorial. So in this case, our n value is 10. We are looking at 3 heads. So this would translate into 10 factorial divided by 3 factorial, and then 10 minus 3, which would obviously be 7. And then you would end up getting 10, 3, and 7 factorial. And the way we define factorial, if that's again something you're not familiar with, is you actually write it out till you get all the way down to 1. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Same thing with 3 factorial, that would be 3, 2, 1. And then 7, of course, would be 7, 6, 5, 4, 3, 2, 1. So as you can see, all those same numbers can be canceled out because we're still writing it as a fraction. 3 times 2 is 6. So 6 can go into, well, actually, we may be able to do this separately. 3 goes into itself once, 3 goes into 9. 3 times 2 goes into itself once, goes into 8 4 times, and go ahead and multiply the remaining, and you would end up getting 120. 3 times 4 is 12. 12 times 10 will give you 120. So that's just a quick description on what that formula of a combination looks like. So you have the combination as the first part over here. Oh, sorry. And then you have the probability to the x power. So that's the next part of this formula. And then the last part is where you do 1 minus p, which is then raised to n minus x. So that's the entire formula. Now, since we are using 3 as the number of heads that we have, everywhere that you see an x, that number will change to a 3. So all of these will become 3. Our number of trials in each experiment was 10. So everywhere you have an n, that becomes a 10. And then obviously the probability was 0.5. So wherever you see p, it becomes 0.5. So this will basically end up becoming a combination with 10 trials and 3 heads, which we know this guy comes out to be 120. Multiply that by 0.5 raised to the 3rd power. Multiply that by, which in this case, 1 minus 0.5 will actually also give you 0.5. And that's 10 minus 3. So that will actually come out to be 7. And then, throw that into your calculator and you will be able to get an answer. You can also use, if you don't have a handheld calculator, you can use Desmos. Just go to their math tools and the scientific calculator. And Desmos, if you actually go under the function, you will see it actually gives you a built-in calculator for that combination. So in this one, you will actually type it as 10, 3. So 10 represents the n value, 3 represents the x value, and you will see that comes out to be 120 as we expected. Multiply that with 0.5 raised to the power of 3. Then multiply that by 0.5, which was the 1 minus p portion. And we raised that to, I believe we had 7 over there. And you will see this is what our probability comes out to be for 3 heads. And that will be our answer over here, rounded up to 5 decimal places. So do you see how this formula works, guys, for the binomial probability distribution? Yeah. Another thing that you can do, you know what? I'm actually going to paste this answer over here for a minute and show you the built-in formula over here. Okay, so for a built-in formula, because obviously Google and Excel have their own built-in formulas too. So for this combination, it will be this combine, COMBIN. So same thing, you will do 10 for our number of trials. And since this number 10 will always stay the same, I'm going to put those dollar symbols around it. So that's going to be 10, comma, your number of heads. And you can obviously type in 10 and 3 in there, guys. Number of heads is going to be 3. So I'm just going to click on that cell. So this will give me the combination, which is that 120 as we expected. Then I'm going to multiply this with our value of P, which is 0.5. And again, since that value will stay the same, I'm again going to put dollar symbols around it. This one has to be raised to, again, the number of heads. So I'm going to click on 3 again. So that's my P to the X portion. And, if it helps, which it might be better to do it this way, go ahead and put this in parentheses so we know this is the P of X portion, then multiply again. And this is where we do the 1 minus P. So again, you can use cells to do it, or you can just type in 0.5 in there. I'll leave that up to you. But since I'm keeping it as 1 minus P, that will need to be in parentheses and then raise it again. And this one will be 10 minus 3. So click on 10 again, since that's a static cell. I'm going to put dollar symbols around it again. And then 10 minus 3. So you will see 3 is the only number that will keep changing as we go to different number of heads. That's why around that cell of D7 where my number 3 is, I'm not putting any dollar symbols in, because when I copy and paste this, I want that 3 to change to a 4, right? I want that 4 to change to a 5. So that's why around that cell D7, I did not put any dollar symbols, but the rest of them, because the N value and the P value is not going to change. N is always going to stay 10. P is always going to say 0.5. So that's why I use the cell with the dollar symbols on it. Or like I said, just type in the number 10 and 0.5 if you want. And you will see we will end up getting the same answer as we did from our calculator over here. Just rounded to 5 decimal places. And now when I take my cell and copy this down, you will see this will automatically change it to the cell D8, which is where I have 4 heads. For the next one, it will change it to cell D9, where I have my 5 heads. So, that's kind of what we are going for over here. So I will leave the first one, but I'm actually going to delete the other 2. So, you want to do this calculation by hand. I've shown you how to do it by hand. So use your Desmos calculator, or if you have a handheld calculator, do it based on that. Or you want to use the built-in function. So you have this formula to look at if you want to do the built-in function. So go ahead. I'll give you guys some time to go ahead and calculate your probability for the number of heads. And then I have one last part to show you once you guys are done with that. And if you will give me a quick second, this person keeps calling me, so I don't know why they are calling me over and again. If they call me one more time, I will try answering the phone to see if it's important or not. But right now, they're not here, so we're good. So if anybody has 3, you already have an answer to verify with. So I know one of you had 3 heads. So you know what answer to expect, but then for the rest of you, Let's see what answers you come up with. And, of course, those of you who have repeating numbers, like I said, once you've done that calculation, you're literally just copying and pasting it for the other one. Alrighty, let's see. Okay, Ali, looks like you are done. Mm. And like I said, you can just type in the numbers for n, x, and the p-values also. You don't have to use the cells to do it. So if that would be easier for you, if you're using the built-in Google Sheets functions, then you can also just type in the numbers and, change them for the three different values you have for your heads, because the n and the p-values will stay the same. So you should be able to do it that way too. All right, Caitlin, I see you are done with your table. Montserrat, did you need any help? It looks like I'm seeing some errors in your table over there.
Yeah, I'm so confused,
Okay.
to be honest. I'm like freaking out right now.
No, don't freak out. It's okay. Okay, so I see like in the first one where you have the 5 heads, you have the combination function. Now in the parentheses, you want to type in 10 comma and then your number of heads. So that would be, 10 comma 5.
Oh, okay. So 10 comma 5.
Yeah, so that would take care of that combination part, the first part of your formula.
Just no. Oh, okay. I see what you mean.
Yeah. Now, after you got the 10 comma 5 done, go outside the parentheses and then you would type in the multiplication symbol. So, from your keyboard, you can type that in. So, that's the little star asterisk on top of the number 8.
I think it's that one, or no?
It didn't show up at my end yet. So yeah, just go after the parentheses after you've typed in the combination, and then you would be typing in the multiplication.
And then that would be what, minus 10 too?
No, so the next part is the p to the x power. So you would then type in 0.5 raised to number of heads, which is 5 again for this first one of yours. So you would have 0.5 raised to the power of 5. And for that, you would be using the symbol which is on top of the 6, you know, the little caret symbol on top of the 6. So that is what we use for raising anything to a power.
Okay, and then I have to multiply again, right?
And then you multiply again with 0.5 again. And this time you are doing 10 minus 5, which would again be 5 in your case. So you would be repeating that 0.5 raised to the 5th power.
Okay, sorry, I'm like, let me look at it. I have it written down. Minus.
Yeah, Mariah, I see that you used the cells and the formula in there. All right, very nice. And that worked out wonderfully because yeah, your 7 and 7 is the same. Let's see. All right, Rachel, you're done with your table.
So I don't have,
ahead.
I don't know if you can hear me. So I don't have to do like the whole money sign E and then like the money sign and then the number.
I mean, if you want to do it, you can, but if you just want to type in the numbers, you can do that also. It will work either way.
Okay.
Okay, so Caitlin, you asked me, how do you type in the probability of getting heads on a scientific calculator? Are you talking about like doing this P of X calculation on your calculator? Yeah. What kind of calculator do you have?
Well, I was using the TI-30X one that I have, but
Yeah.
then I just decided to use Desmos instead.
Okay. So if
So
you're
you
using the TI-30X, you know, your, let me pull that up here. TI-30X. Okay, so it's actually going to be under this probability button that you are going to find the NCR key. So the way the calculator will work when you try to do the NCR is you will actually have to type the N value first. So you would actually first do 10 on your calculator. Then you would go under probability, you know, use the right arrow key to get to NCR. Then you would hit enter and then type in the 3. So on the calculator, it works a little bit differently than Desmos will do. Because
well, I'm fine with learning on Desmos too. I just wanted to write it down for like future.
Okay, so on Desmos, it would be, oops. So Desmos, you would actually first, let's go ahead and clear this out. So you would actually first select the NCR, and that's going to be under the function option. So first do the NCR, and this is where, you know, of course, you would do 10 and 3 or, you know, whatever your number of heads is. So you would do that. Then if you want to use the multiplication key here, you can use that over here or just, you know, shift and 8 on your keyboard. Then you would be typing your probability, which is 0.5. To raise it to a power, you will have to use this, you know, a to the b, because this will always do a square and we don't want that. So you want to click on the a to the b key. So click on that, which gives you the little exponent. And again, our number of heads is 3. So that goes there. You then have to use your right arrow key because we have to bring that cursor down back to the bottom level. So use the right arrow key on your keyboard, bring it down. We do multiply again. This was 1 minus P, which would be, again, 1 minus 0 0.5 would be 0 0.5. Back to that A to the B key. So we get our exponent again. And this time it was 10 minus 3, which would be 7. Now, if your number of head changes, let's say you have actually, I don't know, 6 heads, then this number here will change to a 6, which means 10 minus 6 will actually give you a 4. So that's kind of how you will keep adjusting that. Now,
Right.
guys, if your probability was different, you know, our probability was 0 0.5, but let's say for any other example you are doing and your probability is 0.125. So in that case, be careful because then 1 minus P, you know, obviously is going to be a different number. Because this will come out to be what, 8.875. So just be careful because this has to be the 1 minus P in there. So just be careful about that based on, you know, whatever experiment you're doing. But with this ones, they both come out to be 0 0.5. Caitlin, does that help? Yeah, awesome. Montserrat, how are you looking?
So I'm doing it on the Desmos calculator, and I think I got it.
Okay.
Could you check my answers to see if they look like they
Yeah.
are right?
Yeah, I will actually, and I'm going to try and see if we can reduce these down to 5 decimal places. There we go. All righty. So let's go ahead and check these answers. So you will see at the bottom of our page here, I actually created a table so we could see what it looks like as you go from 0 to 10 heads, because remember I told you the possibility, depending on, you know, what your answer comes out to be, you can go anywhere from 0 to 10 heads. So I'm just going to do our formula here quickly. Our number of heads is 10. Number of heads for the first one is 0. Multiply that by our probability. I'm probably going to do parentheses on that. We're going to raise this to number of heads again, and then multiply it once more with 1 minus our probability. And then again, raise it to, what was it, 10 minus our heads, oops. Okay, so that's our combination, P to the X, 1 minus P, N minus X. Okay, so look what happens when we complete this table. Just gonna pull this down. And look at our little table over here. Just look at number of heads for 0 and 10, number of heads, you know, 1 and 9, and you will see those probabilities come out to be the same, because, you know, it makes sense in this particular experiment because getting 0 heads means all of them were 10 tails, right? So 10 tails, and your probability being the same because it's 0 0.5 for landing on a head or landing on a tail. Since those two probabilities are same, that's why your probabilities are matching, because 10 heads means, you know, is the same thing as 10 tails. So that's why 0 and 10 have the same probability. If you look at 9 and 1, oops, okay, didn't want to do that. 9 and 1 also have the same probability because that means you have 9 heads. When you have 1 head, it means you have 9 tails, right? So again, 9 tails and 9 heads would have the same probability. So you will see that is going to be true as you keep moving down this table. So 2 and 8 have the same probability. 3 and 7 have the same probability. 4 and 6 have the same probability. And then, 5, of course, is the centermost one. Because I know one of you had 4 and 6 in your number of heads. Yeah, right there, Rachel. So that's why you ended up getting the same probability for 4 and 6. And you can see that was 0.20508. So you should be able to compare your answers looking at the table that I completed and see if you had the right answer or not. So I'm looking at Montserrat, your 7 is looking good. 6 is looking good. 5 is looking good. Obviously, then all of you who have a 5, you should have the same answer, 0.24609. Ian, you had a 2 in there, which was 4395. Yeah, that's what we have. Looks like Ali, you also had a 2 in your experiment. So yeah, so it looks like you guys have the correct probabilities here. Caitlin, you had a 3, which you had my 3 to compare that answer with. So it looks like not a whole lot of variety because most of you ended up getting 5. And then some of you had a 7, a 6, and a 2 to give us a little bit of variety. But you can kind of see with some of those other numbers how this comes out to be. Now, this is not going to be true for every binomial probability experiment because it depends on what your basic success probability is, right? And if that is not going to be the same as 0.5 for both head and tail, then those numbers are going to change. So it's just kind of interesting how those probabilities influence your binomial probability also. So this is the first part of your experiment over here, guys. Then the next thing you are going to do is actually compare your answers that you came up with this binomial probability distribution table over here. And these guys are only rounding it to 3 decimal places. So again, your number of trials is 10. So we will actually need to go down to 10 for this, which would be on the next page over. There we go. Whoa, wrong direction. Okay, so just to show you very quickly, where's our 10? There we go. So you've got your number of experiments, which was 10. Your number of heads will be over here. And then our probability was 0.5. So you will actually be comparing your answers with this one. So you will, of course, need to make sure, since these are in 3 decimal places, you will be comparing your answer with the 3 decimal places to make sure your numbers match. Because if you have done your calculation correctly, which it looks like you have, those numbers have to match for you. So that's the second part of this. Now, the third part is where you will actually be calculating the mean and standard deviation based on formulas coming from section 6.1 and 6.2. 6.1 is going to be just the basic probability calculation, and the 6.2 is going to be specific to binomial. Okay, so you will be doing those 2 comparisons, and then the last part is just discussing what makes sense, what does not make sense, why they match or why they don't match. And then the very last part is you are just doing a little graph for a binomial distribution and talking about its shape. So your graphs will look a little bit different if you look at the ones in the textbook because you guys only did 3 experiments, right? So you should only have 3 bars in your graph for this binomial probability distribution. And again, guys, there's no video recording for this one. You will be recording all your results in Google Sheets or Excel, and then your conclusions, you can put them in a Word document, or you can put them, if you want to type it at the bottom of your table, you can do that also, or you can turn it in separately. So I'll leave that up to you. But just make sure that you are showing me how you did your calculations. If you are using the built-in function like we did here in this table, then I can definitely see your calculation. But if you're going to be using Desmos, then I just need you to write down, the formula for each of those 3 experiments that you did. So I know how you came up with your answer, because I want to make sure that you are on the right path. And obviously, I also want to see calculations for the mean and standard deviation, because I want to make sure that you put in your numbers correctly and you got the right answer. So I will need to see calculations for the binomial distribution table. If you use built-in ones, then obviously I can just go click on that cell. But if you are using your calculator, then write those down, and then the calculations for mean and standard deviation. So please make sure I can see those calculations. So any questions coming to mind about these guys? Okay, and obviously I will be available if you have any questions, so don't hesitate if you get stuck on anything and you need extra help, okay? All right, guys, have a wonderful day. I will see you next week, but if you have any questions, you can stay back and I'll be happy to answer. So take care, everyone. Be safe, and I'll see you next week. Bye, guys. Be careful.
Thank you.
Thank you. Bye-bye.